Firstly, I will give you an overview about this presentation. In the background section, I will try to explain the importance of CNN. You know, CNN is accurate everywhere. Also, I need to prove that CNN needs to speed up because CNN needs to tensor computations and convolutions. Also, it needs large storage because you need to store many parameters. Secondly, I will show you an improved CNN version, which is lookup-based CNN. Then I will propose a new hardware technology to accelerate the LCN. And last, I will show you some preliminary experimental results. As you know, the convolutional neural network has been the main way to solve a lot of problems, such as computer vision and speech recognition and natural language and so on. Also, some benchmarks of CNN, for example, the ARINET5, the MLP, ResNet, has shown that high accuracy. However, CNN cost is high, so for instance, ResNet, which is a benchmark of CNN, which has 61 million parameters and 1.5 billion point operations, which need this 61 million parameters needs a lot of frequent memory access. And for a mobile device, the mobile device require more than 3 frames per second and a tight power budget. So it's hard to run CNN on a mobile device with these requirements. So some previous work proposed and has realized that there are some redundant information in the weight of CNN. So you can use small vectors called dictionary as a new weight matrix. And for traditional CNN in one layer, there are many weight matrices. And in this LCN, there is only one shared dictionary. So the conclusion is that LCN can reduce computation and storage during the training and inference step. Let me show you how the LCN works. If you, the W represents the width of CNN. So if you want, in order to compute the one column of weight, if you want to compute this one, the only thing you need to do is you look up the same position of the index matrix, which is 6, 13, 30, which represents the position of the dictionary. You need to look up the 6, 13th, 40th position of weight, and then you need to look up the this coefficients matrix, and which is 0.3 and 0.6, 0.4, and then you need to multiply these coefficients with the dictionary you look up. Then you need to do a sum operation. Then at last you will get this green column weight. if you have some questions about the LCN, you can see this paper and talk with me offline. And what techniques can be used to accelerate the LCN? The one answer is use IRM crossbar. You can see this picture. There is a resistance matrix. So this is a 3x3 resistance matrix. And this is a voltage input vector. If you want to do a vector matrix multiplication, you can map your vector on this voltage input vector, and your matrix can be mapped to the resistance matrix. Then in one clock cycle, you can get the result of one vector result at this, which is also a voltage vector. Then you need to convert the voltage to a digital voltage, digital vector. Now let's see how to build up experiments. The table 2 shows the benchmarks I will use, with some a lot of versions of CNN. And the table 3 shows some other accelerators. So next I will compare these other accelerators with the accelerator I proposed. Some preliminary results show that there is a trade-off between the performance and your accuracy. You can see the x-axis represents the dictionary size, and the y-axis represents the top 5 accuracy of your benchmark. You can see that the dictionary size increase, and then your top 5 accuracy will increase too. And the second line represents the FPS. You can see this FPS. FPS means the frames per second, which represents the performance. So if your dictionary size increase, then your frame per second will decrease. So you can see the trade-off. And the second figure shows with your dictionary size increased, and then your energy per test will also increase. Let's see the last picture. The x-axis represents the benchmark, and the y-axis represents the frame per second per watt. And the right column represents our accelerator, the DKR and the DKRF and DKRA. Compared to the other accelerator, you can see our accelerator in the frame per second per watt is better than the other existing accelerators. Any question?
What will you deliver at the end of this project?
You mean?
What will you deliver? What will you deliver at the end of this project?
You mean the?
What will you submit at the end of this project?
Sorry, what's the end?
For this project, what will you submit?
What will you submit?
Yes, as a result.
The result and some table figure. You mean the hardware? How to prove that I can?
Yes. Yeah.
Hardware?
Yes.
Okay. I only in my experiment, I only use. Firstly, I calculated the number of operations about a CNN such as AlexNet, and then I know how many operations can be performed in this hardware.
So you will submit a C++ or C or Python simulator for the lookup table-based simulator. For the lookup table-based CNN, right?
Yeah. The code of LCN has been proposed. Right?
But you are working on a hardware, an accelerator. So you will create a C code to predict the performance and the power of that accelerator. And your design is based on this resistive bar, crossbar, right?
Yes.
Okay. Okay.